We are on higher derivatives, and we'll start with a word problem there. Find the acceleration of a ball tossed vertically in the air. There we go, keyword there, huh? From ground level with initial velocity 12 meters per second. Do you remember the position function for acceleration due to gravity? Or Galileo's formula, by chance? I think that's right. Yeah. So if we have position, plug in the numbers we have, right? What's the initial height? That's height. So you're okay with S sub 0 means initial, right? Initial position. What's velocity, initial velocity 12? So the how do we get to acceleration? Derivative, right? What's the derivative there? We are all in the same boat.
Yeah.
Slow, slow, slow. Kenny, what's the derivative?
So it's 12 minus.
Okay, and we need one more, right? Second position derivative, derivative of velocity is acceleration. Anybody care to take a stab at that very difficult derivative? Okay, so acceleration, there's no variable, right? So there's our acceleration due to gravity, which we know that by now, probably most of us. But just a little practice in.
In Miss Doyle's class, she's having us calculate the deceleration and acceleration with just the position function, and I've struggled.
Dude, just use the derivative.
I still
That's
do
what
that.
I've
On our
been
mini
doing. That's what I've been
quiz
doing.
yesterday,
She tells me
or on
I'm
our
supposed to
test,
show my
that's
work.
what I did.
Yeah, and like, how are you supposed to what?
We gotta solve it using
Tell her
algebra.
I will grade your work.
Okay. It's so easy just to put a line in it. Oh, that's the derivative.
Because that's like 10 seconds worth of work.
Yeah, especially as soon as she starts giving us like actual equations instead of just numbers.
Yeah.
It would be so much easier if we could.
Oh yeah, it's crazy.
Oh,
I want
she
calculus-based
knows.
physics.
I know.
I feel like I have fun with it, honestly.
I bet we would.
We could teach calculus-based physics class.
I would love to.
But it's schedules.
The only problem is I've never even taken a real physics class. I had physics in high school. No wait, I had,
We'll wing you.
quote, physics in high school.
What was it really?
I knew more math than the teacher that was teaching it.
We'll
Well,
wing you.
that explains
Yeah.
a lot.
Okay, so here's the position function, right?
Sure.
Can you draw the velocity function? What's the velocity here? 0. So we know that the velocity is going to be 0 right there because that's the slope of that line, right? Positive or negative here? Negative here, positive. right? The velocity is always decreasing, right? Because it's still decreasing here, even though it's just becoming a bigger negative. So it's going to be something of that nature.
Aren't, when you do the, when you take when you draw the derivative of like a parabola, isn't it always gonna be a straight line?
Linear, yeah. You just have to determine positive, negative, and zeros. It's super easy. And then what is the acceleration? Oh, let me label.
It's constant, it's just.
Yeah, where though? Negative 9.8. So the acceleration is down here. Negative 9.8. Right. Then you got your 3 derivatives, or your 2 derivatives in your original. You okay with that? Is it kind of bringing back fond memories? Because you guys hated this last year. It was like, I can't go back. It's just 0. Positive and negative.
Really tough.
Okay, let's do this. On your papers, copy this graph down. So this is the function. Just approximate, it doesn't have to be perfect. Draw the first and second derivatives. If somebody wants to draw it on the board, take a volunteer.
Oh, it's weird. Never gone on this before.
It is kind of weird at first. Yeah, give you that. Yeah? Anybody disagree? Okay. That's the first derivative. What about the second? Where's the 0? Say stop.
Well, figure out around
Right there. Are we positive or negative over here? Negative, so we're just going to do this number. Right? And then the third derivative, because we can keep going. Yeah, we don't know the exact slope, but it's positive somewhere. And how about the fourth derivative? Yeah, it's going to be 0. Remember, after 3, we just put a number there. So, okay. Huh?
Let's go on 5.
You want to do 5?
Done.
It's negative 0. What if you are given
What function has the most derivatives?
the infinite polynomial? It has an infinite number of derivatives.
Touche.
Let's not do that because we'd be here for a while. In fact, I'd probably die soon. Let me think of a good function here to use. This is the derivative. Can you draw the original?
A rough sketch of
Yeah, that's what I mean. Why?
Isn't it absolute value? Is it just a
This is a fourth, quartic, yeah, instead of a cubic. So that's one way to identify. Right, so what's our original gonna be? A fifthtic?
Probably gonna go with that.
whatever?
A fifthtic? A
I
quartic?
don't know what the.
It's a quintic,
Oh, yeah.
okay? That's one way, if you know how to draw that. Here's, what are these points gonna be?
The peak.
Zero slope, right? Because this is the derivative, so we know there's going to be a horizontal tangent line at each of these points. Okay, the question is it above or below the axis? Okay, this slope is positive, turns to negative, correct? So slope is positive, turns to negative, that matches here. And then it's probably going to follow this pattern of some kind, right? So we got another 0, goes from negative to positive. That's not exact, but it gets the job done. Whoa. Right? So be able to go between those words. Forward and backward. Okay? All right. This is a very, very common problem to show up on the AP exam, are problems like this. You're given some function, you're given the areas of the function between the function and the x-axis, some points, some zeros, and they ask you to do a bunch of stuff, right? This is a graph of f prime, so we always want to do this. Circle, okay, because sometimes it's f, sometimes it's f prime. Make sure you got straight which one it is. Okay. It's a differentiable, twice differentiable function f on a closed interval. We have horizontal tangent lines. Okay, when the areas are given, here's our initial value. And notice it's not f at 0, right? It's f at 8. Okay, so if anything we do, we're going to subtract out that direction. Of course, we're not in integrals yet, so not a big deal. Find all values of x in the open interval, 0 to 8, for which the function has f has a local minimum. Justify your answer. How do I identify min and max? From on a minimum? Yep. So remember, minimum starts with negative, goes positive, right? How about here? No? No? Okay, so there's our local min, because we have a 0 that goes from negative to positive. That's all you'd write. There is a minimum at x equals 6 because f prime changes sign from negative to positive and has a 0. Done. Okay. Determine the absolute minimum. That requires using area calculations.
So, wait, I thought when you did absolute, you just had to consider that.
So you do consider the zeros and the influence, right? So this 0 is a possible absolute min. So is that. So is that. Okay. Is this a possible absolute minimum?
It's possible, but it's not there.
Why? Okay. Why can I say no?
With the area.
Yeah, you've added value because the area is positive, right? So this is a higher point than this one. Okay. Is this an absolute minimum? Why not?
Since it starts at that point, it completely, doesn't it?
The graph starts here, goes up in value by 2, by 6, so it goes up 8,
Yeah. and then
down
there's
3,
five.
so it's still plus 5.
So that one's still 2, which is lower than 5, so it's still gonna be balanced, right?
This is the absolute minimum. Because you've added 5 in value, you've gone up 5 to get to this point. Right? Does that make sense? So it's just a logical argument. This is the absolute minimum. This is still a minimum, but you know, the function's gonna look, it's gonna go up 8, down 3, up 7. So down here's the minimum. Again, we'll get more to that when we get to integrals again, but, okay. Remember, second derivative is concavity, so we want the graph concave up and increasing. So what do we need for concave up? Or concave down, sorry. Second derivative is negative, or derivative is decreasing, right? And where is f increasing? That's where the derivative is positive, right? You processing? So since we have f prime, we can go with f prime is decreasing and f prime is positive. Where's that happening?
0 to 1.
0 to 1. 3 to 5. Jump 3 to 4. Here we're negatives.
Oh,
3 to 4, so only here.
Yeah.
And nowhere else, right? So we have 0 to 1 and 3 to 4. Good to go. We will get more detailed into that stuff, but just refreshers. Okay, part B. The function g is defined by g of x equals f of x to the third. If f of 3 is negative 5 halves, find the slope of the line tangent to the graph of g at x equals 3. Okay. We need g at 3, right? Is f at 3 cubed, so negative 5 halves cubed is? Negative 125 over 8. Yeah, and then we need g prime at 3, right? What's g prime of x? This is chain rule. All right. Again, we'll go over that in a couple days. I'm saying that a lot today, huh? But chain rule that. 3 times negative 5 halves squared times f prime at 5 halves, or f prime at 3. 1, 2, 3 is, can't see it.
4.
It's 4. Yep.
Why do you
Huh?
Why do you do this?
Because I make the same mistake all the time.
Okay.
We're human. You can all score 100% on the AP Calc BC exam. I will stop doubting you. Okay, so just a small look into a free response with some derivative work in it. Okay. Any questions? Loader. Okay. That's it for me. Here's your book work. The AP problem is posted on yesterday's, obviously. And AP2, 17 to 20. There we go. Hopefully you're pretty fast on those. Let's see. But I think you do have about 15 minutes, so take advantage of that. Yeah. 10 maybe.
Like
21 through 26, 39 through 41, 17 to 20, and an AP3 response. Looks to me like you're going to get lots of AP practice this